Historically, I've been teaching the lecture test method for years and years, and in the mid-90s I went to a conference on physics education, and it was really eye-opening, because what they were saying is that using a traditional method, a very small percentage of the kids really get it, and there are other ways to do it where you can dramatically up the percentage of kids that are really understanding what's going on. This unit, as most of the units in this course, are based on research that was done at the University of Washington. They came up with a method of teaching that involves small groups of kids physically working with equipment on the table. In this case, they had photos of pulses on a spring. They would kind of line them up and figure out how fast the pulses were going and answer questions about them. So what I did is, because our kids all have laptops and we have a slow motion video camera, I shot these pulses moving in slow motion, and they can stop them, they can back them up, and more importantly, they can import them into our video analysis software, so they can actually measure the speeds of the pulse and the speed of each part of the spring that it's moving on. Rather than just saying, pulses are of these types, memorize that, here's an example, here's a test question. They start by looking at it and forming their own idea, and the terminology and the equations and all that kind of stuff is built on the basic idea that they get by just looking at it and making sophisticated observations like how fast is it going and things like that. In the sense of how effective the student's use of time in the class is, it's far better because they're engaged during the class. They are thinking about the subject matter more or less continuously throughout the period. Whereas if you sit and listen to a talk, your mind can wander, and it will wander. So that's one thing. But another is the understanding of the concepts themselves is much more thorough, because the questions that we ask the kids, or the things that we ask them to do, is address commonly known misconceptions so that they disabuse themselves of the wrong ideas first before you then build the right ideas in their heads. And I shouldn't say you build, they build the right ideas in their heads, which is again why it's more solid understanding than if they're just told things and manipulate symbols. It's taken a lot of work, but over the years I've been able to do a lot of development of my courses along these lines. I introduce them to an idea, maybe takes a minute or so, but everything they do is in their group doing it. It's guided by the handouts that I give them, but within that context, they're fully engaged, and that lasts for the whole period. The kids are actively engaged for the entire period. It's a dramatic difference. There's been research in how kids learn physics best, and the results of this research show that the traditional way of teaching is not very effective. I want to pass on not just to my kids, but to the school, a better method that reaches more kids. That's my goal.